This is module 7, and we're going to talk about machine learning using Python. Now, even before I go here, right, I have something to show to you. Just give me a second. Let me share my PowerPoint presentation now. So now in data analytics, right, you would ask me as to, so far you have gone through so many things, right? How is it helping you in data analytics? Now, I've been telling you the biggest challenges of all data scientists throughout, right, has been to to give a problem statement from a set of data that they see. If you know your data perfectly, and if you know the problem statement, 70% of the work is done. I mean, it's a huge challenge to know the data, and first of all, so as to identify what a problem statement is there and what is it that you want, right? That's a huge challenge. So these are the steps that we normally do, in data analytics. Do it using Python or any other language, it's the same, but because Python, they call it as a language of data science, it's mostly used. I mean, I personally use Python in doing all these things, okay? But you can do this in R, and there are other languages as well, which can help you do the same thing. Now, content from users, content from machine, this is collection phase, right? Let's say, for example, I'll be taking you through one of these projects at the end of this class, wherein we will scrap the data out of web, right? You might be thinking, you might be seeing a lot of data in web as of today, and then, if you are, if you are a little analytically bent, you would have thought someday as to, if I could just pull this data and do my own analysis, right? Let's say you go to any website. Let's say you go to Amazon.com. Like, let me pull out all this, toys or whatever shoes they have, and then let me do a price analysis, right? You would have thought about this someday, because just to go there on the website, click each of this, let's say, Nike shoe and Reebok shoe and do a price comparison. It's a difficult task, and you would have seen there are many applications already available in the internet which says that compare this insurance product with that insurance product, and then we give you the proper price comparison, and then you can go ahead and buy whichever insurance you want to, right? I mean, they use big terminologies. Maybe I'm sounding a little more simple here. They would have used better terminologies. That's it. And what is it that they do? They just go to those websites, scrap those data, find out the prices, just do a comparison, put it on their own website. At the back end of it, it's just some beautiful super scrappy might be running, but then their front end would look good, and then you'll feel like, wow, this is the product that I wanted. So Python, the first phase is collection phase, where you can use beautiful soup, scrappy, BS4, etc., right? So those are some of the packages which helps you in collection phase. Even you can use Flume for that matter. Flume will pull data from Twitter, or you can use some of this graph, graph languages, Facebook graph to pull the data, Facebook data, right? And those are all data collection. Scoop also, I guess. Yes, Vishnu, absolutely. It's just the lists are endless, the way you collect. I mean, even maybe just to collect the data, maybe an SQL query is also fine at the basic end of it. But anything that helps you in collecting data, basically that's what we are talking. So this is collection phase, right? After you have collected the data, what do? You store the data. Now basically in all this, right? Do you want to store the data in, let's say, relational database? Right, and you might have data in JSON format, text format, structured format, database format. Where is it that you want to store the data? So that's another decision that you have to make. Do you want to store it in MongoDB? Do you want to store it in HBase? Do you want to store it in Hive? I mean, how is it that you want to store the data? So that's the next step. See, the reason I'm explaining you this is, right, because at the end of the day, whatever we are studying, we are studying in order to solve a data science problem, and we are not just trying to learn Python for the sake of it, right, to do simple analysis. No, that's not our intention. Our intention is to learn Python so as to process the data, right? so as to be able to do data science on it, so as to be able to devise an algorithm on top of it. So that's the reason why I'm explaining you this. Now, okay, this is an interesting problem. Now, I want to find a genre of a movie, okay? Now, whether it is a romantic movie, action movie, okay, or any other type of movie. In my example set here, I have just romantic and action, okay? And this is my problem statement here, okay? This is the movie title. Let's say some movie, Beautiful Woman, right? Okay, Beautiful Woman is there. So some movie, I mean, just think of some movie which has the number of kicks in the movie are 18, number of kisses in that movie are 90, and I have to predict the type of movie. Okay, I have a example as well, which I'm going to run you through towards the end of this class. I mean, today itself, right? I have a data set on this movie data set, which I'm going to run a pandas program and then show you as to how we do this KNN algorithm. But as of now, you just have to tell me as to how do I predict this, okay? And what is this distance that's calculated? And in KNN algorithm, right, this is also called as K nearest neighbor, okay, wherein you provide the number of K's, that means the number of result outputs or level that you have, and based on that you predict your outcome. That's KNN algorithm, okay. I'll be walking you through that in my, I'll be walking you through this KNN algorithm in detail. I mean, I'll be walking you through the pseudocode, a code as well, but right now, you'll have to tell me based on this as to how this is predicted. Okay. Now let's go here. Now you see this California Man, right? How was the distance from to movie calculated? Now number of kicks and number of kisses. Now you see this number of kicks in my question mark movie. So in this case, right, the distance from movie, this movie here, which is in question mark, which is 18, and your number of kicks in California Man is 3. So we calculate some distance called as Euclidean distance, right? Now if you calculate an Euclidean distance, which means 18 minus 3, which is 15, right? And 90 minus 104, which is 40. So the Euclidean distance is square root of this distance, x2 minus x1 plus y2 minus y1 and square root. So your Euclidean distance will be something like this. Okay, your Euclidean distance would be calculated at x2 minus x1 plus y2 minus y1 and square root. Okay, so this is your Euclidean distance. Now in this algorithm, what we take here is 18 minus 3, which is 15, and 104 minus 90, it is, okay, now this is square, this square, and this square, okay. So x2 minus x1 square plus y2 minus y1 square into square root. So what happens in this case? Let's take a small calculator and calculate it for us. Now in this case, right, 18 minus 3, 15 into 15, which is equal to 225, right? And 104 minus 90 in this case, 104 minus 90 is 14. 14 into 14 should be 196. That's what I think. Let's see. Okay, 196, right? So 225 plus 196 equal to 421, right? If I take a square root of it, I get 20.5. So my distance to the movie is 20.5, right? So you understand this now as to how this distance would have been calculated, right? So after you have, and then it's similar to, he's not really the dudes. It has a distance of 18.7. Beautiful Woman has a distance of 19.2, so on and so forth, right? And that's how now you will be able to predict as to what this question mark movie is. How do we do that? And I've already told you one thing, that KNN algorithm, you will be providing the key, right? That means the number of results from where you want to compare whether you can classify whatever problem statement you have in this example as romance or action. Now let's say, for example, I start with KS3. Okay, so KS3, what's the least distance from here? Let me take this here, right? In case of this one, right, my least distance would be 18.7, 19.2, and 20.5. So guys, have you got this? I mean, this is the concept of KNN algorithm. Okay, it's pictorially I have explained to you what this is, and I'm going to quickly run through a program on this as well. Now, see, these are the significance of KNN algorithm. KNN algorithm is a type of instance-based learning or lazy learning where the function is only approximated locally and all computations is deferred until classification. Okay, after you provide the training set, everything is done, and finally you have this classification done. It's at the end. It's KNN algorithm is the simplest of all machine learning algorithm. Basically, all you have to, the input of it will be a data set as well as label, and then you'll be able to predict it as to, what your result will be for whatever question mark data that you have. So, it's a K is a positive integer, typically small. So I'll tell you, for large numbers, right? For a big algorithm, you can decide K using some parameters, which I'll share you. In KNN algorithm, the output is a class membership, okay, and object is classified by majority votes with its neighbors. That's what I've told, right? I mean, if you have 3, 4, whatever, the output is decided by voting mechanism. Now, these are the pros and cons of KNN algorithm. Pros: high accuracy, insensitive to outliers, no assumption about that. In this case, there are no outliers, right? It considers everything. Now, outliers are some dots outside the cluster, okay? Which when we talk about K-mean algorithm, we are going to talk about outliers as well. But in this case, there is no outliers. Cons: it's computationally expensive, high memory requirement, because every time it calculates the question mark data that you have, it calculates all the input data as well. It runs the training data set along with it. So the memory requirement is high, and then it works with numeric values, nominal values. I mean, basically values. Now, general approach to KNN. It's first of all, you collect the data, you prepare the data, right? It's not just with KNN, it's with any other algorithm, right? Any other algorithm, it's the same. You collect, you prepare, you analyze, and then you train the algorithm. Train the algorithm in the set. Let's say you have a huge set of data. How do you first of all cleanse the data, and then you run your program on that data so that you get correct output, right? So if you know that 0.5 size tumor is malignant, if you pass that data, you should be able to get that as a malignant. So that's how you are training your whole algorithm. And then you calculate the error rate, and you finally use it. Okay, fine. There is a technique to calculate the error rate as well. Number of total number of input and total number of accurate result. That's how you get your error rate, and you'll be able to identify as to what's the probability of your algorithm being accurate. Now, building a classifier. Okay, let me run this for you. Now, see, in this example, right, all I have done here is I have provided this is training data set, okay, 1, 2, 3, 4. There are this is an array that I'm passing, and for this 4 array that is being passed, these are the labels or output, okay, and this is the logic, whatever I have explained, okay. It calculates the difference metrics, and then you have square of distance, and you get the difference metric. So whatever logic that I have explained you using simple words for my data here, that's exactly the same thing that I've done, okay. So, and then there is finally this voting mechanism. So what we would do is, I would run this once. Okay, and you see this one. Okay, this is just compiled. Now what I would do is, I am trying to classify my new data set, right? This is a new data set that I have, right? 0.2 and 0.1. Let's go back here. See, 1.0 and 1.1 would give an output of A. 1.0 also gives an output of A. 0.0 will give a output level of B. I mean, it's the data set that I have, okay? And 0 and 0.1 has an output level of B. Now, why do you have duplicates in the label list? So that's the output, right, Rakesh, for each of the data. Let's say, for example, that's a training data set, right? Let's say, for example, my 0.5 size tumor is malignant, right? So 0.5 and output is malignant. 0.6 is again malignant, so that's again M. 0.7 is again malignant N. But 0.8 is not malignant, so N. So you have to have, for each of the data sets you provide, you also have to have a level or output associated with it, right, Rakesh? Okay, excellent. Now you see this. Now what I do is, this is my problem statement, the group and level that I have already defined. This is the training data set, and what's my K here? 3. Okay, so when I do this, okay, this I do not have to print this, it will just confuse you. Now the result label in this output is B, right? So let's do a comparison of my data from here. Okay, let me print this and do a comparison of my data here. Now you see this 0.2 and 0.1, right? 0.2 and 0.1, it is nearest to which one here? I mean, even otherwise, if you just have a look at it, I mean, human brain, I mean, you can infer as to what this data can be, right? See, 0.1, it's near to 0.2 and 0.1 is near to 0 rather than 1, right? So the output would be B here. Now if I say 1.2 and 1.1, right? What should be the output data be here? It should be A. So this is a very basic, simple example, okay? You have the code here. You have the code here. Just run through it, and you know, this is a very small, basic example that has been created so as to give you guys an example, right? Just go through this once, and you'll be able to understand. Whatever explanation that I have done, it's exactly the same thing that has been done here, and we are just building a simple classifier. Now the distance calculation might not necessarily be Euclidean. You can have other type of distance calculation. You know, you can implement some other type of logic even in KNN, right? That depends. And with machine learning, right, there's no one right answer, okay? And you get a correct answer after repetitive, you know, trial and error method. There is no way you can just go ahead and you know, be able to find out this is my algorithm, this is the data, and this is the output that I should get. There is no such method here. You know, there's no hard and fast rule. It's all trial and error. You'll have to keep on applying different types of algorithm until you finally get the correct result. Now this is how you build a classifier for every point in our data set, right? Calculate the distance between X and current point, which I've already explained actually with that example. So you should be good with this. And sort the distance in increasing order, right? Finally, you sort this distance in increasing order. Take K item with lowest distance in X. Find the majority class amongst this item, which is nothing but voting, and return the majority class as a prediction. So this is written in words here. I just explained using an example. Okay, so okay, now this is how you can run. This is I have run this. You have seen as to how you get an output. Now testing a classifier. Okay, classifiers are not always correct. That's why we have different types of classifiers. there are different things that impact the performance of classifiers, such as settings of the classifier and the data set, right? If you have a huge data set, if you have a huge data set, obviously it will take more memory, right? If you are executing a big data set, because at any point in time, you are not just passing the training data set, but you are passing the problem statement as well. So obviously it will be memory intensive. Different algorithms perform differently on different data sets. Okay, if it is it's string, it's different. If it is numeric, it's different, so on and so forth. But basically, we do classifier for your numerical and nominal values, which should be which should be numbers basically. Now, and even if it is not, you have to devise a way in order to find out. Let's say malignant is 1 and non-malignant is 0. That's how you assign values. Now, error rate. Test the classifier with known result. This is what I said. This is R is number of wrong guesses by total number of tests, right? This is the error rate. Error rate of 0 is perfect classifier, and error rate of 1 is classifier is always wrong. So this is how you look into it. Now, so that was about KNN algorithm. Okay. Now we have another set of problem called cluster. Now this is not problem, which is another set of algorithm called clustering algorithm. What is a supervised algorithm? The simple reason being is that you provide everything, right? You provide the case. Since we knew the output, yes, the base. I mean, we have provided the input. We already know the label or output, and then we are trying to predict for a new value that we are providing, or for a new input, we are trying to predict the output. So that's why it's supervised, right? So. But if you come here, clustering, it's an unsupervised learning that automatically forms cluster of similar things, right? This is unsupervised algorithm. It's like automatic classification, okay? And it's just that you provide how many, how many clusters you want, and then it will give you clusters. You can cluster almost anything, and the more similar the items are in the cluster, the better your clusters are. I mean, inside a cluster, things should be similar, but outside, if there are two different clusters, the clusters should be different, right? But inside a cluster, almost all the items inside a cluster should be similar. We are going to study one type of clustering algorithm, which is called k-means. It is named as k-means because it finds k unique cluster, right? In k-means, you provide k as a number, and that will provide you unique clusters, and the center of each cluster in the mean of values, basically inside that algorithm, inside k-means, you have one vital thing called as a centroid, okay? We'll see that as to how that is done. Clustering versus classification, the key difference between clustering and classification is that in classification, you know what you're looking for. That's not the case with clustering, right? In classification, you know what you're looking for, right? You know whether it's 1 or 0, or it's, it's malignant or non-malignant, right? But in case of clustering, you do not know that. Clustering is sometimes called unsupervised classification because it produces the same result as classification, but without having predefined classes. So it's able to cluster it. If you were to take the same example of malignant and non-malignant, it would cluster malignant as one group and then non-malignant as some other group. Basically, both of these can do the same task, right? But these are two different ways of writing an algorithm to do the same task also. K-means algorithm. Now, the process by which objects are classified into a number of groups so that they are as much dissimilar as possible from one group to another group, but as much similar as possible within each group. Now you see this group 1, group 2, group 3, group 4. So the definition says that each of these groups has to be very different, but inside this group it has to be very similar. The objects in group 1 should be similar as possible, but there should be much difference between objects in group 1 and group 2. It's okay, I think it's self-explanatory. You'll be able to understand this. The attributes of the objects are allowed to determine which objects should be grouped together, right? Because of these attributes of these objects, it will be decided as to which objects should be grouped in which cluster. Now, here you see, basic concept of cluster analysis using two variables. We have, high income and low balance group, and then here high balance and low income group. So these are two clusters, right? That's how it is created. Let me take you through. Okay. One second. Okay, that's fine. So basically, all this is trying to say is that you can divide this gross monthly income into two different categories, wherein you have high income and low balance, and high balance and low income. The objects in cluster 1 have similar characteristics, high income, low balance. On the other hand, the objects in cluster 2 have the same characteristics, right? This is how you have divided your cluster. But there are much differences between an object in cluster 1 and cluster 2. So this is just one basic example. Okay. Now, how do we do this? This is the main question that comes to our mind, right? How does this happen? Okay. Iterate until stable. So, this algorithm will continue to iterate over a set of data until and unless you have found out a proper cluster. Okay. So, determine the centroid coordinates. So, let me explain you apart from this word. So, how this happens? You have a set of points, right? You have a set of data. So, the first thing that happens is that in K-means algorithm, you also provide K along with the data, right? So, you already have a training data set, and then you say, I want K cluster. So, first of all, it just, it takes the K and then randomly assigns. Let's say, for example, you have a data set with 10 records, okay, and you have provided K, which is 2. So, first of all, it will go and randomly select 2 points as centroid, and will calculate from those 2 points. Now, let me explain you this using MS Paint. Okay. Now, let's say you have these points, right? Okay. Now, for the first time in K-means algorithm, are you able to see my points? Okay. Hopefully, you are able to see. I'm trying to make it a little bigger. Okay. Okay. Thank you, Sundar and Naveen. So let's say for the first time when it goes here, right, it will randomly select 1 and 2. Let's say it selects this as a centroid, and then after it has selected each of these as centroid, right, it will calculate the distance from here to here, here to here, from each of the centroids to all the points here, right? From here to here. Okay, this might not look a pretty example, but I have a pretty example already in place. This is just for the explanation. Okay, so what it does is that whichever points are nearest to whichever centroid that we have selected, right? Let's say these 3 points are nearest to this. It forms a cluster here. First time, it forms a cluster here. Now, but then is this the centroid of this complete circle? No, right? This centroid might be somewhere here if there were to be one more point here. So what it does is it will take mean of this distance. Okay, let's say this is the mean of this distance. Let's say this is the mean of this distance. This is the mean, and then it will form something like this. Okay, and then again to that point, again it will take mean, and finally it will find its centroid here. Likewise, it will find the distance from here to here, here to here. All this distance it will find, it will take the mean, and finally it will find out whichever is the centroid here. Now, it depends on your algorithm as to whether, now this is just a simple example I have given in when you are dealing with this type of clustering problem, right? You are dealing with millions of points in your coordinates, okay? There are a million of points. So, right now, it's like there was no point here. So, in these cases, your algorithm will be intelligently able to define which is the nearest to this one and then assign that as centroid. But when we are talking about a real life scenario, you will have some point here and then this will become your centroid. So this is how the total, the clustering of a problem is done. This is how the clustering algorithm works. And now let me take back to you to our slides. So this is what it's explaining. Okay, whatever I have explained you. In MS Paint, this is what it has been explained. Number of cluster, start with number of cluster, which is k. First of all, you find the centroid, right? That's what I said. Randomly you take 2 centroid, okay? In our example, you took 2 centroid. Distance object to each centroid, you got to know this as well. Grouping based on minimum distance, I did this as well. This is the grouping, right? Based on minimum distance. And finally, no object move group. This is about finding your centroid, okay? The first time it might find something as the centroid, and then this is a repetitive task. It will go on iteration over iteration. It will go on many iterations, and finally you'll be able to find your centroid. So this is a repetitive task. It goes on over iteration, one iteration to the next iteration to so on and so forth, and finally you'll find your centroid. And that's what it has been explained here, okay? Now this is one simple problem statement for k-means clustering. The newly appointed governor has finally decided to do something for the society and wants to open chain of schools. Guys, even before I go there, did you understand k-mean problem? I mean, that was the simplest way in which I could explain k-mean algorithm, okay? Now, implementation wise, it depends upon how your data sets look like, how many parameters you have, and so on and so forth. The implementation might be completely different and very complicated than how I've explained you to this. But the basic, the moot point, the whole concept about k-means algorithm is what I have explained it to you. Makes sense, right, guys? Is the k in k-means needs to be determined upfront? Yes, Naveen. Again, for that also you have a ways to determine, okay? Now, see, inside an algorithm there is one more algorithm, right? This is more like one algorithm within another. Or can this be changed during processing? Once you have provided the input as k, it will make, in my case, right, I provided k equal to 2. Now you'll ask me how will I determine, right? As in KNN algorithm, here also you'll ask me the same question, right? As in, how do I determine the optimum number of k? More than KNN algorithm, it makes more sense for you guys to be asking me the question here. And again, there's another process, there's another algorithm for it based on the data. Yes, Naveen, absolutely based on the data. But let's say I have millions and billions of records. How would you determine, you know, what should be your k? There's another algorithm for it. I will share with you as to where you need to read all this data from, because machine learning in totality is a completely different subject. Okay, it's a complete vast course. It's a vast subject wherein you need to know statistics and there are many other things, right? In lot more detail than how we are discussing it right now. You know, everything is a formula over here. So I will share with you what is the formula and what is another algorithm. You know, I'll put this in LMS. I'll ask the support staff to put it in LMS so that you can have a look at it. For simple problems, you know, you can decide the k, but for complicated stuff, I mean, you cannot do that, right? You would not know as to how would you classify that. Okay, so let me go here. Now, the newly appointed governor has finally decided to do something for the society and wants to open a chain of schools across a particular region. Keeping in mind the distance traveled by children is minimum so that the percentage turnout is more, right? So, poor fellow cannot decide himself and has asked his data science team to come up with a solution. Okay, but these guys have the solution to almost everything. But this is a clustering problem, right? After I've explained you this, you'd have students scattered over places, and then you cannot have you know, schools in every street. So you have to make only 2 or 3 schools, and then you have to decide the optimum number of students who have to travel less to that school. Now, this is the exact problem that I gave, right? If k is 4, it will select randomly 4 points here. The 4 points are centroid. From each of the centroid, it will select distance to the students here, and you know, we take up random data points from the space and find out the distance from all the 4 clusters, right? This is what I did in my example as well. If the data point is closest to the pink cluster, it is colored pink. So whatever is closest, then it makes 1 cluster here, 2nd cluster here, 3rd cluster here, 4th cluster here. Now there are outliers points also, right? Because this is closest to this, then this or this, right? So this is under one group. Now in this iteration, right, there are a couple of things. One thing that I missed out saying is that not only does the centroid move, there is exchange of point between different clusters as well. Excuse me guys. Sorry for that. So not only this, right? Like I told you, I mean, I gave an example of this centroid moving. You know, this after you have taken one circle, right? After this centroid has been created, you know what happens next time is that the centroid moves. Let's say the centroid moves here, and then the centroid moves here, and this point maybe which was part of this initially now is not part of this, and then this centroid is near to that. So even the points which were originally organized as one cluster and set of points as second cluster will also move. That's the iteration which happens here. Yes, Sayyid, the result will vary depending on the value of k, absolutely. If you have just two clusters here, right, in this example, if you just had two, maybe this would have been as part of one cluster and this would have been part of second cluster. But because you have four, look at how this data point will change, okay? Now look at how it has changed now. Now you had pink points here, and then, green here, and then red here. Now finally, after all these iterations, you see this here. Now this has so much in its cluster, this has so much, this has this much, and then the green has so much. So the cluster has changed. The output will definitely change based on your, and finally in my final iteration, it's even different. See, that's how it looks like. Makes sense, Sayed? Make the point at which you would have started, right? Let's say you took point 1 and you have point 1 to 10. You would have started point 1 as a centroid and end up being 8 as your centroid, and the rest is its point or its cluster. This is how k-mean clustering is done. Actually, it's an iteration, so you just have to write your code and then run through it. Now, this is one question here, which I would want you guys to respond. In cluster analysis, objects are classified into a number of groups so that, guys, answer please. Okay, Naveen says 1. Vishnu says 1. Sayed says 1. Deepesh 1. Sundar 1. So basically, you guys understood it, right? So excellent. Let's take it forward. Option 1, we all know that. Now, and see, will we find the optimal solution of this clustering problem, right? We might get in a local minimum and not a global minimum, right? So it depends upon, it's not necessarily that you find your optimal solution. You might find your nearest, whichever is your centroid and a cluster surrounding it, but it might not be the optimal solution. Okay, so you can just pass k multiple times. Let's say you start k2, k3, k4, just for your practice, right, whenever you're doing it, and then see as to how the centroids are converging or not. Now, how to find an optimal solution? Choose first center at random. I mean, this is one technique, okay? There's no hard and fast rule, okay? This is just one rule, or do many run of k-means, each with different random starting point. You can do this as well, okay? And or you can choose first center at random, choose second center that is far away from the first center, okay? If you have just 2 clusters to make, you can choose 2 extremes such as 2 centroids, right? And then you can choose your center as far away as possible from the closest of centers one. So that's how you would do it. Okay, see in this case, right, I started the base, let's say I had 1 point here, right, and then I had 1 point here. So finally there should be a point in time wherein my centroids wouldn't move. That means it would have converged. Okay, and after first iteration, let's say my centroid moved here. Third iteration, the centroid moved here. Fourth iteration, it would have moved here. Fifth iteration, it came here. Sixth also same. Seventh same. Eighth same. Ninth same. So it has converged, right, Dipesh? It's not moving beyond that. Got it? So 1, 2, 3, 4. If you had point like that, after your first round, let's say you started with this as a centroid. After the first round, you got this as a centroid. Because centroid is moving. Okay. After all this calculation, like I told you, right, the centroid would move, even the data points will move. The centroid moved here. In my third statement, in my third iteration, the centroid moved here. Fourth iteration, the centroid moved here. And even in my fifth iteration, it's the same. Sixth, it's same. Seventh, it's same. The center has converged. It's not moving beyond this. So that is where we know that the center has converged, and this is the centroid. That's one of the logic of KNN algorithm. Okay, excellent. Now choosing a number of clusters, you can use this elbow method as well as to how do you find, you are asking as to, how do we find K. You can use an elbow method to find K. Now this is a big equation. I'm going to share that with you guys as to how do you find this K. But for now, just for your benefit, right? Just understand it's an elbow method. Okay, we'll come to the equation part of it later. I'll send you the equation. Now, so basically in elbow method, what it does is, you have the number of clusters here. You have given the number of clusters 1, 2, 3, 4, 5, 7, 8, 9, 10. How many ever clusters you want. Okay, sure, Syed. So let me go back here. Okay, let me explain to you here. Okay, Syed wants to know, can you please explain how centroids are formed quickly? Okay, sure, Syed. Don't say. Syed, let's say I have these points. Okay, this is 1 point. For this, I want to have 2 clusters. Okay, my intention is to have 2 clusters, right? Let me start with this as a centroid, and let's say the farthest point here, this as another centroid. Okay, this and this as centroid. So the way it calculates for the first time, it will create a cluster based on the distance. Let's say this distance from this centroid to every point, it will calculate the distance. Sorry, it's not going in a straight direction, but I intend to put this straight. Okay, it's not going. Now let's say this is 1 meter, 1 meter, or 2 meters, so on and so forth. And from here to here, let's say it is 3 meter. So now for this centroid and this centroid, this is for this point, this is nearest than this, so this will go to this cluster. So let's say, for example, I got this cluster based on the distance. Are you able to get it till now, till here? Okay, excellent. Now after you do that, right, this is one cluster, that this is another cluster, this is 1 number cluster, this is second number cluster. Now it will calculate the mean distance from each points. Let's say this was 2 meter, the mean would be 1 meter, right? Let's say from here the mean was it was 3 meter, so mean would be 1.5 from here, somewhere here, right? So at some point you'll get all these points like this, right? So the centroid for each of this point would be different here, right? And then slowly again it will calculate mean. This is an iterative process. It goes here, it again calculates mean, again iterative process, and finally it converged at some point. Okay, so after having calculated the distance for the first time, it starts calculating the mean from each centroid to its point here, right? It calculates the mean. Now this mean becomes the centroid from this point to this point, right? If you take a mean, this becomes the centroid. For a 2 point, this and this, the mean is the centroid, right? For each point, you calculate this mean, and then finally there will be a point wherein the centroid will not move for all the points. Okay, and that is taken as the centroid of the cluster. Make sense here? Yes, no, say it, and anything. I mean, if it is no, I'll explain it to you fast again. So it has 2 centroids at the end. Yes, that's what we started, right? We wanted k equal to 2 cluster. So 2 cluster will have 2 centroids. Okay, excellent. Now in elbow method, right, the way it is done is that you have this objective function value, okay? You have all your values. Let's say you have Euclidean distance, right? This is a big number, and then you have number of clusters. So at whichever point there is an elbow-like bend, right? In this case, there is an elbow-like bend. You see this? It came down falling drastically, and some point it stopped falling. So that's the point where you figure out what your k should be. So don't worry about this. I'll send you the equation, and you can have a look at it. These are all statistical equations, so have not noted it down. It just I'll send it after the end of this class. But this is just one method, okay? Choosing the number of clusters. There are various other methods as well. Now, okay. Moving forward, general approach to k-means clustering. This is again same, right? Guys, do I have to repeat myself? I don't think we would need to do that, because it's the same with all other algorithms. Again, you have to first collect the data, you have to prepare the data, you have to cleanse, cleanse the data whichever way you want. You analyze the data, and then you train, because you analyze the data for a problem statement, right? You analyze the data, you train the data, and then finally you test it, and then how you use it. That's how you use it. So this is clustering. You have load data set, distance, Euclidean distance calculation. You have random centroid, calculation here. So all these functions you can use this, and then this is k-means. It finds the closest centroid here and then updates centroid location. Just have a go it at once, and if you don't understand, please let me know. It's the same thing. Okay, whatever I've explained to you, that's how it has been used here. Now, one thing I wanted to say was, okay, this is fine. Okay, I think, okay, I was just thinking about something to explain, but okay, anyways, I think, that's about it. You got it. Just go through this, run a clustering problem if you have, and you use this code, or you can write your own code as well, and just test it one. It's similar to KNN. You can run clustering problems with k-mean as well. Okay, now at this point in time, now we'll go into pandas, installing pandas as it is with any other package installation. Pandas installation is also very simple. It's if you are installing it in Linux, all you have to do is sudo apt-get install python pandas, or if you are installing it in your PyCharm, all you have to do is like I've been showing you, just go to your settings and then just install pandas. Okay, here it is. Just install. Just search for it, pandas, and just install. So that's about pandas installation. Now, what is Panda? Right? Pandas is an open source BSD licensed library providing high performance, easy to use data structures and data analysis tools for Python programming language. And like I've been telling you, it's built on top of NumPy, SciPy, and to some extent Matplotlib. Right? It has taken some of these some of the better features of NumPy, SciPy, Matplotlib, and then they have created pandas. Pandas is well suited for many different kind of data. One is tabular data, ordered and unordered time series data, arbitrary matrix data, and other forms of observational statistics data sets. Now you'll see some of these things, right, while I load the data, and the way some of these statistics are being done using pandas is it's extremely powerful, and it's beautiful. You do not have to calculate all those mean, median, standard deviation, etc. One statement and everything is done. So that's how simple pandas make. And also it can also do some of the stuff that Excel does. It's like almost like whatever pivot does, pandas is able to do that. So that way on a metrics data, it's pretty powerful. Now the purpose of pandas, we have been talking about analyzing data, cleaning, munging, modeling, so as to be able, so that we can feed this data to machine learning, right? Who does that? Pandas can also do it. Your ordinary Python program can obviously do it, because that's what pandas is based upon. It's built on top of that, but pandas has been specifically designed to to work on metrics and other statistical data. Now, primary data structure of pandas. Pandas has two primary data structures. One is series, which is one-dimensional, and the second is data frame, which is two-dimensional. Okay. When you think of data frame, you can think of some Excel in your head, and you'll be able to understand. It's a two-dimensional data structure. In one-dimensional series, it's one-dimensional labeled array capable of holding any data type, right? So now let me go here. Okay, 1 second, right? So if you do this, okay, so all I'm doing is I'm trying to put this list ABCD into list, and then I'm printing that. Okay, okay, here you go. So whatever ABCDE here is in my list, right, you get that along with its index. Okay, and the data type of that is object. It's an object data type. So this list is printed as along with this index here. So let's go here. So this is series. Basically, you can have any series. You can provide your own index. You can provide customized index. You can also have numerical or non-numerical index. You can have special characters as index, so on and so forth. Basically the point here is that you can have an index created on the data. That's series, and it is one-dimensional. I see a question here, but I'm coming back to that. And a two-dimensional data frame, it's a data frame which is two-dimensional. It's a two-dimensional level data structure with columns of potentially different types capable of holding, right? It's basically two-dimensional. Think of an Excel sheet. That's how you can think of this. The basic method to create a data frame is to call data frame. Now the difference here is for series or one-dimensional you call series, and for data frame you call data frame. Now, yes, Vishnu, it converts in something like a key value pair. Yes, you could see that. Values and index, right? Index values. Now, D and index can be any dictionary of one-dimensional array. Okay. Here in this case, D and index can be any dictionary of one-dimensional ND array, list, dictionaries, or series, etc. So we will see that while we are going through this example. Now these are a lot of stuff here. Okay, we'll go and see them one by one. Now, see, like I told you, right? In this example, these are my values. Okay, this is again some other type of list. These are again some other type of list, 9, 7, 8, 6, some values, and then my index is star, double star, triple star, etc. So let's go and see as to how it works. Now, if I print series here, it gives me C star is 9, double star is 7. That's how it has been given here, right? This value has this index. Now, if I go to series and then say, what happens here? Star. Okay, let me try to differentiate that. Now, if I do in this case here, if you look at this closely, the index has star, double star, triple star, and 4 star, with each of this representing some data here, 6, 8, 7, and 9. So if I have to pull this data based on some index, as I do for any other normal index, right? I say series of star and then it gives me 9. If I say series of double star, likewise, it will give me some other value, which is in this case 7. Okay? So now, and then if I have to fetch multiple values, right? I can do this here. Inside list, I'm passing both star and double star. You see here, inside my list, see, that's how I'm able to access the data. Now, these are some of the simple operations here, and we'll see the powerful operations now. Okay, let's first cover some of the basic stuff. Okay, one more example here. In this case, right? Now you see what I'm doing here. I'm trying to print 2468, and then I get that along with index, right? 2468 0 1 2 3 4 3. This is the index, and I have assigned 2468. Now, if I specifically assign some values, in this case some characters here, now that becomes an index. So likewise, like how I did for some star, I can do this here as well, right? I get 2. Okay, that's how it can work. So these are some of the simple operations, and in this case, right, let's just a second. 0 1 2 3 4, I have these values. Let me go to my example here. Now let's say, for example, I have something like this. Now what happens here in this case? You have range is your values 0 1 2 3, and your list has, index has a list which is AB AB. So when I do print of S3, this is very important when you are slicing and dicing the data, right? Mostly if you are trying to do machine learning and you are trying to deal with some kind of data where you want to do statistical analysis, then this is the package that you need to go. Now look at this here. I have range which is 0 1 2 3, which is my value, and list AB AB. I have duplicated index as well, AB AB. Now how do I access A's, all A's here? I just do an A, and then I get both the values here. In this case, right? Okay, one second, let me print S3 first. Okay, so now in this case, if you see here, A is 0 and A is 2. A is 0 and A is 2. So when I just do an S3 of A, I'm getting both 0 and 2. Now what if I only want the first values? How do I get it? Let's say I just want 0. Any idea, guys? Okay, I'll give you 30 seconds. So my problems here is that my S3 has some data 0, 1, 2, 3, and this is the index A, B, A, B. Okay. All I want to know here is when I do print S3, I'm able to get the entire one-dimensional array, right? One-dimensional series. And if I do S3 of A, I'm able to get A of 0 and A of 2. If I do print S3 of B, okay, I get B1 and B3. Guys, are you able to at least hear me? A smiley or whatever, a small character Y will also do. I'll be able to understand that you're still with me. Okay, Naveen says I'm with you, Rupesh, okay, Sundar. Okay, thank you guys. So, Sayed, okay. Anyways, so guys, here I have, when I do S3 of A, right, I'm able to get both these values. So any guesses as to if I want only one value here, how do I do it? How do I access a list? So let's see what happens when I do this. Okay. Will this work? Yes, it does. See, it's just giving me one value. Let's say B of 0 as well. See here 0 and 1. S3 of A of 0 is 0, S3 of B of 0 is 1, right? That's what it is. Something like, okay, Vishnu, it's, okay, Vishnu has given a response. You're just near to that, but this is how it will work. Nearly worked. This is how we'll access the matrix later, Vishnu. You're not completely wrong. This is how we'll access the matrix. Okay, so now, yes, two-dimensional array, correct. Now, see, we have been seeing, what is it that we have been seeing? We have been seeing that we provide the values and then we provide index. What happens when we do this? A dictionary like value already passed. See here, it gives me S of data as a dictionary only. So, will I be able to access the values individually? Yes, I am able to do that. So even while you pass these values, right, even while you pass some dictionary like values instead of list, right, all we have been seeing here in the example is list, right, everywhere. This is list, 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 and so on and so forth. Now, even if you pass dictionary, you are able to do the same thing that you are able to do with a list. Now and then if you have to make this as, but this was a plain dictionary, right? This was a plain dictionary. If you have to insert this in your series, which is a panda type, all you have to do is you have to provide this data inside my series, and then it will just work as one-dimensional series. See here. Just to not confuse you. Okay, so like you have been working on list, this is an example of how you can work on dictionary as well. Simple example moving forward. Okay, there is one more thing that you can see here. See, this is S data is your dictionary here, and then you have provided A, B, C, D as your list, right, which is an index. So when you do print, we'll see, we'll try to differentiate this and this, and then what happens is that your B, C, D, it matches. Okay, so let's go here, right? You have S data, so watch this carefully. Okay, S data is, you have a dictionary of B, C, and D, right? This is key and this is value. B, C, D key, you have some value here. But then if you provide your own index, right, which is of type list here, and then you're providing A, B, C, D, B matches with B, C matches with C, and everything is fine. But for the one, it did not get any value, it just applied, it just put NaN. Okay. So that's how, I mean, that's why pandas are very powerful. You know, some of the missing data. So it's assigned. It's not as such a value. It's just saying that it's not null. Okay. So pandas are powerful in the sense that it is able to identify whichever are missing data and then it assigns something to it. I mean, Vishnu, that's partially correct. It's assigning something, but it's not exactly the data that it's assigning. Okay. So that's about it. I mean, and then it's able to match internally. Look at the programming that must have gone with inside it, right? So when you do this, it just a matching of this to this, and then whatever is matching, it will retain the same. Whatever is not matching, it will apply NAN, so on and so forth. So there's a lot of work that has gone inside pandas. And then you can also do this. What will happen there? Yes, it will. I'll show an example later on, Vishnu. There's an example that we have. Okay. So here it goes. When you do S5 into 2, S5 was this ANAN 100, 150, 200. Now when I multiply it by 2, it just multiplies with all the values of the series. Okay, makes sense, guys? Also, moving forward. Random 5, this is fine. Now, data frames, right? This we were talking about series. Now let's talk about a little bit about data frames. These are just a basic concept that I'm walking you through so that we'll be able to understand some of the complex stuff later. Now in this case, I have taken a series. Okay, it's again like a key value pair, right? If you see here, I've taken this is as a column name. You can think of this as a column name, and I've taken a series which has certain index. I've taken another 2 series, which is again another certain index. I pass this complete series data, which is again in these braces inside my data frame, and then let me print my data frame now. Okay, so when you look at the data frame, this is column, right? Column value. If you compare this with Excel, now you'll be able to relate to it more, right? See, you just compare this with Excel. On top of your Excel, you write your column names. So this is your column names. These are your values, and this is your index A, B, C, D. Now, in my first example, in my first column, right? In one column, I have only 1, 2, 3. So 1, 2, 3. Whereas I do not have an index called D. So in this case, it's just null. There is no value here. In my second example, in my 2 column, I have 1, 2, 3, and 4 as values, and I have index A, B, C, and D, right? So it will assign everything properly. Make sense? This is how your data frame would look like. Now, this is my data frame. One here, you're able to see data frame. This is another similar example, right? 1, 2, 3, 4, which I'm not going to show. And anyways, this is what I'm going to share with you, so you can practice it yourself. And now, when you do D1, it's the same thing again. Data frame, print of DF. Now also the other thing that you can do here is data frame of, I just want one column. How do I do it? I just get one column, right? That's what it says. You can do 1, 2, and then you can also add a new column to it. Let's say I want to add a new column. So you can manipulate this as well. So whatever you are able to do with Excel sheet, most of these data science individuals, right, data science folks or data science scientists, in any office that you might see, they will work a lot with Excel. I'm sure you would have seen that. Your business analyst works on Excel, your data analyst works on Excel. People just like to work on Excel, right? So you need some feature which are, which are in, so while creating pandas, right, they thought of a feature which are similar to Excel, and then they started putting these things in there. So whatever you do it in Excel, you can do this here as well, but with ease of coding, and you can automate the whole process that you can do in Excel. Not that you cannot automate the whole process in Excel. Excel is quite powerful. It has its own macros. You can create your own pivot, etc. But it's just that with programming here, you can slice and dice the data. You can cleanse the data. You can automate the data. You can create jobs which will run automatically. So there are, it's much more than Excel. But the idea was to give them something which will help calculate, or which will help data scientists in order to find a solution faster. Now, if I want to add a new column, let's say I have only how many columns? I have 1 and 2. Let me just comment this. If I do this, and all I'm doing here is I'm taking the column 1, multiplying by 2, and assigning it to my new column. That's the new D1. Okay, data frame D1, it's not defined, right? Correct. So it's my data frame which has been defined. So this is how it is, right? You had 1 and 2 as the column here, and now I have 1 column, 2, and then this is a new column, which is a multiplication. It just multiplies with 2, 1. 1 into 2, 2, 2 into 2, 4, 3 into 2, 6. That's how it is here. Okay. We have just like 2 plots on 1 graph. I mean, it's more like a matrix. Now this will be 3 into 3 matrix, right? In this case. Okay, you didn't get me. Okay, so here your data frame is like a matrix, Vishnu. In this case, it's more like 3 into 3 matrix. Okay. Okay. Great. So now print series, and okay. Here. I'm just trying to show you some things which are important. Other things are here, right? And you can have a look at it yourself. Series. Okay, let me do this. Now I created an object, and okay, this is about re-indexing. I have this index. Okay, excellent. So coming back to my, okay, let me take this back. So to my series, right? Now in case of series, okay, this is my, now you see this, what will this give me? I have green, yellow, and red. I have indexed this at 0, 2, and 4, right? This should print me 0, 2, 4, green, red, and yellow, green, yellow, and red. But what if I have to re-index the whole thing? I mean, those index is not correct, right? It's let's say I had a lot of data, and then something in between got deleted, and then I just have 0, 2, 4, and 0 to 4 index, which I want to re-index now, and this is one scenario, right, wherein you could use this function. So for the first time, your green, right, yellow, and red is 0, 2, and 4. That's fine, but I want to change it, right? I want to re-index it. So what I do is I put object.reindex of range 5, then it says 0, 1, 2, 3, 4, and then your 0 is green, your 1 is NaN, 2 is yellow, 3 is NaN, and then 4 is red. So what it is doing is just putting a value with which you'll be able to identify what are the things that is missing here. And then let's say you want to repeat it, right? you want to repeat some of these values wherever it's blank. So what you do, you say fill values and then you say blank. Let's see what happens now. So wherever you had put NaN, you are able to replace it with black. And what's that? Object 1 equal to green. I didn't get it. Are you able to assign? Do you want to assign something here, Vishnu? Okay, okay. So that will be object 1. So you are saying something object 1 equal to, let's say ABC, right? It does not work, Vishnu. Okay, yes, ABC, it does not work, Vishnu. Okay. So these are some of the features, right? These are some of the features. I mean, pandas has been created so as to do something in, so as to do your analysis on statistical data mostly, and to plot graphs, right? Some of the features of list are available here. So this is more like a, okay, that's, sorry, okay, object. Okay, it works. Some of the so it works like a list. Okay, thank you Vishnu for pointing that out. Yes, it works like a list. Some of these things work, some don't. But basically the point is that, you know, these are things that you do in order to first you know, slice and dice your data so that you can finally plot a graph or maybe provide this as an input to your machine learning program that you have used, right? So now let's see here, and thanks for pointing that out, Vishnu. Okay, so this object dot reindex, when I do this, now you have you know, object 1 equal to ABC. Python is, yes Vishnu, it's extremely powerful. Each of this package is you know, it's a complete book in itself. I mean, Beautiful Soup is a book in itself. Pandas is a book in itself, right? It's more like an independent programming language itself. So okay, so that's about if you want to fill black. Let's say, for example, you just filled everything as black. Let's say, for example, you just want to fill it, right? Which means you want to fill with already existing values. Okay, and what I do here is, now there will be nothing, right? Okay, I'll have to create a new series. Basically, what ffill would do is it would fill here. I do not have, one second, let me run Python. Okay, just a second, I want to show you one more example as well. Okay, it's NaN here, right? So if I do an index and methods ffill, okay, you see this here now. So what happened here was, I had this as my series, right? Green, and wherever it was, you know, wherever there was no data, it just put as none, NaN, and then yellow, NaN, and red, right? Now I just want to fill it with whatever is existing. So it just takes the first value, and then if it does not exist in the second one, it just overwrites it. Takes the third value, right? It prints the third. In fourth, it goes and checks there's no value, so it just overwrites it. So on and so forth. So these are some of the techniques using which you can fill the data as well, for whichever is not there. And this will be required in many cases, right? Many cases while you are, you know, when you are playing around with data, you might run into a scenario where you would need some data instead of leaving those empty. And in these cases, you can use ffill. Now, df.sum. Now we are going into interesting thing. Okay. Now what's df? Print. When I do print df, I have this, right? Now what happens when I do? Now see the power of pandas now. Those were simple stuff that we were looking into. Now if I do df.sum, see 1 how much? 3, 4, 5, 6. Okay, it just summed up all the columns in one shot. For 2's, 1, 2, 3, 4, it just summed it up. 3, it just summed it up, right? If you want to, let's say, for example, find mean, right? Mean. What's the mean of 6? It's 2. 10, and then just 4 values. It's 2.5. Again, you have 12 mean, which has only 3 values. Isn't this interesting? Now, not just sum and mean. Let's say, for example, I just comment this out. What happens now? Let's go and check. You see this count, mean, standard deviation, minimum of the values, 25%, 50%, 75%, and maximum. You see this? Now we are getting to know pandas, okay? Makes sense? Now just imagine the usage of it when you are dealing with statistical programs or statistical packages, etc., statistical data, where you want to calculate, let's say, weather data sets or any kind of other data sets that you might have. Okay. The new column, Naveen, I have just added a new column, right? You see here. You see, I added a new column. Is the 25% of the total values. Let's go and check here, right? So, what's the total value here? 6. And what's the 25% of 6? 1.5, right, Vishnu? 50% will be 2. That's what it is. I mean, it's just, you know, it's for folks who are doing statistical analysis and stuff. You know, they would need this many a times. You know, they would need 25%, 50%, etc. Yes, Deepesh. It's called quartiles as well. Okay, so just imagine, you know, how powerful it is, and we have not even explored, you know, quarter of it. So let's go describe. Now let me go back to our slides, right? And there are a couple of more things here, and there are some things here and some things on my slide. So I'll explain you whatever are the differences. You know this, right? We saw the index part. We also saw, you know, the range. How do we do it? You know, how we can assign index to each of these values here. That's what it has been done here. We can also pull out the series. We can pull out first or second values of that series. We can also re-index whatever is there in the dictionary. Let's say dictionary, I have passed 110, 220, 330, and then I have given index 1, 2, 3, 4. So it will just match 1:1, 2:2, 3:3, and then 4 there is nothing. It will just put NaN. Right? We can use NumPy operations on data. We can just use series into 4, and then it will just multiply everything. 10, 20, 30 becomes 40, 80, and 120. Right? And now data, you have, let's say you have some data like this. It's a dictionary like key value pair data. Key is this one country, and your value is a list. Right? And then if you put that data in data frame, you'll be able to see something like this, which I've explained. Right? See, this country is one column, year is one column, population is one column. Okay. Now, again, it's the same example here, data frame. You have the same example, creation with dicts of dicts. See, only difference here is that you had inside your dictionary, you had a list, right? Key value pair. Key is a normal key, and value is a list here. In this case, key is a normal key, whereas value is a dictionary. Right? For that also you have, and then in this case now, the way it compares is 2012, right? US, India, so it matches the value. 2012 has 30 for US and 20 for India, 30 for US and 20 for India. So each key is a label for its value. This is a key value pair. Now, you mean the output, Vishnu? Yes, I mean this is more like dictionary. You can think of it as an output. You can think of this as any other key value pair as well. I would not say it as a label, Vishnu, as yet. Some key might have value of 10, but some would have assignment of 10 as well. So it is not exactly output, but this one gave no label for year. I mean, we do not have year right here in this case. I mean, this is more like an index in this case. Okay, if you are talking about index and label as the same thing, then it's the same. Okay, Vishnu, I get you. Yes, you are right. Okay. Now in this case, right, you have see this index value key value pair, right, and then it compares both the index, and you have 2012, 2030. Now if you just want to access one part of the column, you can just do that with country as well. You know, you get like this, and then if you want to, and then when you describe it, you already know what you get, right? There are a lot of things that you get when you describe it: mean, count, standard deviation, minimum, maximum, etc. Now you have seen this. How do we add a new column? We have also seen as to how can we add a new column to this. It's simple, you know, you just have to say new column and then you have to put the values. How many ever values you want to put. It's not necessary that it has to have all 4 values. You can have 3 values. Maybe it's a list, right? You can have just 3 values, and the rest of the values will be applied as null. NaN. We have seen how we reindex this. When we do reindex, it will properly reindex this instead of haphazard index here. Fill value Python, again this is you have a range of 6, 0, 1, 2, 3, 4, 5, 6. When you reindex this with range, and then you fill value Python wherever it is NaN. In this case, let's go and see this, right? You have 0, 1, 2, 3, 4. You have NaN, Hadoop, NaN, and Cassandra. So fill value Python will say Python, Hadoop, Python, Cassandra, and then and then whatever is there, whatever extra values is there, it just put R, let's say, and then it just index it. It's very simple. And ffill, we have already seen what an ffill is, right? It will just put if it is for the first time, it will not put anything, because if it starts with NaN, it will just be NaN. Otherwise, it will just repeat whatever is there previously. Okay. And then we can apply individually also. Instead of doing data.describe, what we can do is we can apply functions like sum, min, max, head, count, tail, etc. So, here you do sum, it sums all the columns. You do mean, it gives you all the mean, and so on and so forth. These are simple functions. I'm sure you are understanding this right now, because there is nothing much to explain. It's just that you'll be able to use it, as and when you practice more. I mean, that's how you'll be able to remember and use it. And then when you do describe, that's about it. Okay, now let's go and see how do we load the data. How do we load data in pandas? Now see, it's very similar to other programming language that you might have done. Okay. Now see, I am loading this data. I have a transactions data in this particular location. So this is a CSV file that I have. Some data, okay. You don't have to go into the intricacies of data. This is some data that I'm loading here, and all I want to do is I want to print the data. I want to read the data. This is just about reading the data. So it just read the complete data. So there are lots of record here, and then it's just reading it. Okay. And then see, it's because it's a huge data set. That's dot 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 dot. That's lot more data here. So basically, this was to show you how to read the data. Now Now you can read the structured data. It works fine with JSON, XML, HTML. You can read that as well. You can read Excel as well, but you'll have to use XLRD or Open PyXL. Okay, these are third-party packages. Now you just have to go that and download it. If you have to read Excel, you just have to go here and then you have to import one of these packages. Open XLRD. Let's say I have not installed XLRD. So if I want to do XLRD, I just go ahead and say install packages. That's all I have to do. And then database, pandas IO SQL module, it will be able to read from database as well. You have seen how we do that in SQL-Lite, right? You are able to, you are able to hit that, you are able to create tables, you are able to read from there. You have connectors using which you can connect to databases, pull the data from there, and using pandas also you have input output SQL module. So panda read, that's how it reads. And now my data is not so good, otherwise I could have described it, right? If I say, let's say, this will, because my data DSCRIB, right? So it gives me this, okay? Count is this much, minimum is this much, standard deviation is this much. So for this data, right, it's huge. So for all this numerical data, it just took and it just counted it. It gave mean, standard deviation, maximum, etc., and so on and so forth. So my data did not have my column, so the first record it took as column, right? So that's how you are able to process data in Python. It's extremely powerful. You just have to have data in your Excel sheet, and you can apply one of these packages so as to be so that you can get one of these results. Now going back there, also there are some of the functions that you would want, you might be interested in, like length. So if I say length of data, it will give me the number of records there. Okay, let me comment this out here. I do not want to print this. Okay, so let me comment this as well. Head, I do not want head. Data.columns, right? So you see this, it gives me 49,999 as the number of records, so which is my length of data. Now data.columns will give me all the columns or the first record, right? So it does not have any columns, so it just took out the first data and then it's giving me as columns. So if I just want to print the first 10 records, I can say head of 10, right? It just gives me 10 records, see 0 to 9. Now because it's not able to show it here, it's just that the next set of columns, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the total columns that I have. 3, 3, 6, 3, 9, right? So that's what it's displaying here. So that's about at high level. I think that's about it on pandas, and it's again the same thing. Okay, see these, you have seen this. Merging tables, let me talk about that concept briefly at a very high level. Describe now length of data, columns of data, and see head of 2, you just get 2 records. You can also get functions can also be applied on columns also. So here, one second. So you got it, right? Okay, you have head, tail. Dipesh, you have head, tail. How do we save the data to a file which we can use to see? This is so basically, Vishnu, what we have done is we are reading this. You can open this in write mode and then write it the way the way we have done it, or you can use any other Python modules as well. If you want to use this is how you are opening a file for read and write mode. Make sense, Vishnu? Or you can open some other file for the write mode and then you can write it. it's simple, like what we have done for other Python, read and write. The same can be applied here as well. Yes, Deepesh, to some extent it's similar to R, and Panda has taken the best out of R, matplotlib, etc. So it's similar. If you know R, actually it'll be easier for you to understand all this. Okay. But the advantage with R right now is that you have R Hadoop. Okay, so it's not an in-memory operation anymore right now. You can run R over Hadoop, and this complete. It's altogether different ball game. But prior to that, we just had R, right? With R had its own limitations. So, anyways, let's move on here. Now see, you can go to ID. If it is ID, you just want the two IDs here. This ID, like you just do ID of head of 2, and then you say ID of max, you get max. Simple functions, right? And then you want to draw a graph. I'm not drawing it right now. I'll draw it in some time. You just say data.open, and then you draw an histogram, right? Data age, you draw an histogram of age, and then you just say so for age you plot it. Now, and then you want the first row. We can do it. 1 second. Okay, let me comment this. Let me comment this. Let me comment this. Okay. You see this? So it's assuming this is a column. Okay. First column is assuming it is column, so it's giving me data here. Now see all this I row. So basically, if you were in this page, right? If you were looking at this example, first name, last name, age, and occupation. So here in this case, first name, last name, age, and occupation, including ID. So if you do 1, you get this. If you do 2, you get the second row, and so on and so forth. The ID is 402, 443, 403, and then so on and so forth. Right? If you do 3, you get the third record, so on and so forth. It's very good for analysis. And then there are some more actually. You can apply filter also. You say volume equal to data, and then you give data ID of this 4 and 502. You just get that, right? You filter it based on writer, you get this. Okay, so it works like an SQL as well. Where you are applying your select star from table, where table name or column name equal to value. It works like that as well here in this case. Pandas, we can merge table. It's more like a union. Okay, so how after reading from CSV file, how do you want to save this multi-dimensional array? I mean, then you cannot save it in CSV, right, Vishnu? Then you'll have to do it in Notepad or something, and then you'll have to read it from there. You'll be able to write. I mean, in this case, whenever you do describe also, right? I mean, it's coming row. It might look like multi-dimensional to us, but the way your system would understand the data would be according to the row, right? Each row will be printed. That's about it. Okay. So again, this merging table. Yes, Vishnu. Okay. So you're merging. I think I have an example of merging. It's similar. Okay. Here. Okay. So see, these are the two data frames that I have created. Okay. Let me just take one by one at a time. So what does this do? I have dictionary of range 0, 1, 2, 3, right, which is ID here. You see this is ID 0, 1, 2, 3, and then age is my random number between 8 to 31, and you have the size is 4. So it starts with 20, right, and you have 22, 20, 22, 25, 30. So this is what it has, 18 to 31 with size of 4. Okay. Now my second here, my second data frame is, you know, I have range of 3. Let me comment this so that you're able to understand it better. Now I have an ID which is range 3 plus 3. That means I have 0, 1, 2 and 0, 1, 2 again, and then some random number. Okay, don't worry about this. Some random number of size 6. Now if I have to add those two, what do I do? Okay, let me go here and then print and let me just merge it. Okay, just for a reference, right? Where all I'm doing is I'm doing a pd.merge. Oh, is it Vishnu? My video and audio is not in sync, is it? Now, are you able to look into my PyCharm? Hey Vishnu, are you able to see my PyCharm? Guys, are you able to hear me? Okay. Okay. Vishnu says a lot of video lag. Amit, yes. Deepesh, Sayed. Okay. Naveen says it's good for me. Okay. So I'll not change it that frequently, Vishnu, in that case. Are you able to see my screen now? Okay, I think you're able to. It's good. It's okay. Thank you, Amit. Thank you, Vishnu. So now when I run this, now see in my first place I had age, right? In my second I had score, and ID is same in both the cases, right? So basically all it did was it merged the two. That's all. It took this data 0, 1, 2, 3, 0, 1, 2, 3. Now ID matching 0, 0. So this scores 27 and this 27 and this value. Again there is a matching of 0 with another 0, so it will be 27 with some other values as well, some other value as well. So it's more like you know, you're merging it. It's more like you're doing a union between these two data sets. So that's about it. I mean, you might need this feature whenever you are you know, trying to merge these two data. I have an example here wherein we'll be using this feature. So this is how the data sets are merged. I mean, it's pretty simple, right? I'm sure you're able to understand. It's more like an inner join on the table. So if you think of this as a table, it's more like an inner join. Okay. So this, okay, now let's go to summary. Built on NumPy, SciPy and Matplotlib. Basically, it has taken out the best of the features from NumPy, SciPy and Matplotlib, and then have created pandas. Arrays with labeled access that supports heterogeneous data, right? It's index data. Usually works in conjunction with other scientific stack of Pythons like SciPy, NumPy and scikit-learn, right? Basically, pandas is an combination of NumPy, SciPy and Matplotlib. It has all the powerful features from there. So you can, so as to process your data, you can use pandas, and you know, you can use maybe scikit-learn for implementation of machine learning algorithms on top of this. Have more features than R's data frame, right? So it has actually more features than R data frame, and hence you know, people have are preferring to use pandas over R. Does automatic and explicit data alignment and has group by reshaping, time series functionality, fault tolerant, uses the best feature of the popular data analysis environments like MATLAB, R, Stata as well. So this is what we have been talking about. So applications, pandas like NumPy help solving data related issues, mostly in the field of data modeling and efficient computing. Okay.